Okay, so today we are at the topic 2. So we have finished the first 2 lab sessions in the first week. So now we are going to the second lab session. The second lab session is basically to how do you, from the data set, okay, construct your contingency table and relative risk and odds ratio. So let's do a quick revision. Now, your contingency table will have to look something like that. Okay. You have the condition. The condition is always in the column. So you have a positive condition, yes condition, no condition, and then your exposure. Your exposure is in the rows. Can all of you hear what I'm saying?
Yes.
Okay,
Yes.
good. Okay. Because I have no idea who is who. So exposure will be yes and no. Okay. So this is the result. Then we have the total here and the total here. Okay. So essentially we label this as A, B, C, and D. Okay. So in this case, for relative risk, what is the equation? Anybody can remember off your head?
A bracket C plus D.
A bracket C plus D. Okay,
Yeah.
usually, yeah, it's correct. A bracket C plus D
Over C, then A plus B.
A plus B.
Yeah.
Okay. Hold on, my phone is giving me problem. Okay. But I always find this way of writing to be a little bit tricky. I tend to prefer it to write this way. Okay. So it's A divided by A plus B over C divided by C plus D. Okay. So it's actually the ratio of the positive and the ratio of negative. Although when you swap it out, it's the same. Okay. Now for odds ratio, what will be the formula?
AD.
Oh, now who are you first?
Is
AD
Yeah,
AD
over CB.
over CB. Okay, so it's essentially, if you do it, my way will be A over B divided by C over D. Okay, there are a few rules of thumb that I want to take note. Now, is it possible? Okay, the question number 1 is, can relative risk be equals to odds ratio? Let's find somebody. Trevor?
I don't think so.
You don't think so, right? In most cases, no. Okay. In most cases, no. There is actually one case that RR equals OR, which is when A or B is equals to 0. That doesn't make any sense at all. It's like, why on earth you want to do that? So in most cases, no. But mathematically, it can be possible. Okay. In most cases, no. Okay. So let's say, is there a relationship? So is there a relationship between your relative risk and odds ratio? Or there's no relationship? Let's try Jingru.
I don't think so.
You don't think so? Okay. All right. I will say that there is a relationship somehow. There is a relationship, okay? Although it may not be that obvious. So what do I mean by that? Okay. This is the rule that I want you to take note. Okay. Because of that, right, we infer, okay, if the relative risk, okay, if the relative risk is more than 1, the odds ratio will always be more than relative risk. Makes sense, right? If relative risk is more than 1, odds ratio will be more than relative risk. This is B. Okay. On the other hand, if relative risk is less than 1, odds ratio will be less than relative risk. Okay. So this is almost like for you to check your work. See whether did you put in the wrong numbers for tabulation. Okay, so far so good? Yes, no, somebody give me a sign.
Yeah, okay.
Okay. All right, right. Okay, so let's go to our let's go to our lab. So what we are trying to do is to use this diabetes data set, which is a large data set, and this is an actual data set from a paper, consists of 19 variables on many different subjects. Okay, so it has 398. Okay, original test data set is actually much larger, 1,000. Okay, looking at prevalence of obesity and so on. Okay, and here what we want to note is what is diabetes? Diabetes is by the glycosylated hemoglobin. So the glycosylated hemoglobin more than 7 implies diabetic. Okay, so this is how even most of the blood sugar testing machines, that's how they do it. So let's open up your diabetes data set. Here I call it diabetes work because I want to mess up my original data. So all of you open it up. Anyone do not have this data set? Or have? Okay, so the first thing you open this data set is you have to look through what is all the columns. What does the columns mean? Okay, sometimes it doesn't make a lot of sense. I do not know every single thing. So you look at this. This is the ID of the patients. Okay, so it's a running number. Cholesterol level doesn't give me a unit, but there's cholesterol level. Stable glucose level, HDL, which is your high density lipoprotein. Ratio, I do not really know what on earth it means. Okay, this is the glycosylated hemoglobin. So this is the data that we want to look at. So let me just highlight it in some color, basically a very light green. Okay, so I highlight as I go along. What are the data points that's important for me? Location. Okay, where you come from, Buckingham or Louisa. Age of the patient, gender of the patient. This is the height and weight of the patient. Okay, frame, the body frame, small, medium, or large. BP is blood pressure. Okay, sometimes you measure blood pressure 2 times. Okay, so if the first blood pressure is very high or very low, then you may wait for another half an hour, 1 hour, and you will measure again. Okay, so this is the first measurement. This is the first measurement for your systolic blood pressure and the diastolic blood pressure. Second measurement for systolic blood pressure and diastolic blood pressure, if any. Okay, so this is a waist measurement, hip measurement, and I have no idea what on earth this is. Okay, now, if you look at the values in the data set, what is strange to you? Or can you try to make up the units of the values? Okay, let me just arrow somebody. Lucas, any number that looks strange to you? You have no, that is, you look at it, you have no idea what unit it is.
The height.
The height.
Like, why is it so small or so?
What?
Yeah.
Okay, why not you just type? It's a bit noisy on your side. What unit do you think the height is?
I think it's an inches.
You think it's in inches? Correct. So this height is actually in inches. Okay, inches. How about the weight?
Pounds.
Pounds. Okay. The weight is pounds. Correct. Okay. So automatically, The hip and waist is also in inches. Okay. All right. So what we want is the first step is to look at how many what we call as diabetic or not diabetic. So let's go. So we want to say that if the diabetes data set is more than 7. So how do I read this? Okay. I use an if function. If the cell F2 is more than 7, then I code it as 1. Otherwise, I code it as 0. Okay, means that if it is the value of F2 is more than 7, means that you have diabetes. Okay, 1 means diabetic, 0 means non-diabetic. Understand how this looks like? Okay, so let me rewrite this in clearer English. This means that if cell F2 is more than 7, then you will actually put down 1. Otherwise, you put as 0. Okay, remember these are commas, okay? These two are commas. So let us go there one step at a time. So let me click on column G first. All of you follow me, click on column G. Right click. You right click, column G right click. You go to insert. Basically, I want to insert another column. Okay, I insert, I have one more column out. Any, all of you okay? Okay, because I'm going to do step by step, if you are unable to follow or I'm going too fast, stop me in time. Don't let me go for like 2 or 3 more steps, then you stop me. It's very troublesome. I have to rewind things. So all okay?
Yes.
Yes.
Okay, good. Okay, so now let's say G1, I put down the word diabetes. Or rather diabetic. So it's yes and no, 1 and 0. Okay. Then I highlight this to be maybe a bluish color. Okay, so that I can differentiate. Now, as you go along, you can save this worksheet because we'll be using this worksheet for a long time. And there is one assignment that you're supposed to do. Most likely, you'll be using this worksheet as well. So let's see. Is this patient ID 1000? Is he diabetic or not? Or he or she diabetic or not? Is she? So is she diabetic? Is this patient diabetic?
Nope.
Nope.
No.
Because it's 4.31. In fact, it's probably low blood glucose already. So the only one that's diabetic is probably 6, correct? In this row number 6. Makes sense because it's more than 7. Okay. So we can actually have some way to look at. So we go to cell G2 and you type in if, open bracket, the logical test, click on F2, more than 7, then you put 1, otherwise you put 0. See, it tells you the logical test is F2 equals more than 7. If the value is true, what do you put inside? Otherwise, if the value is false, what do you put inside? Okay. Okay. So if you cannot follow, go and look at my this bar, equation bar. Okay, make sure all have that. All right. Hui Min and Min Hui, any okay? Any problem?
No problem.
Okay, no problem. So if I press enter, I should expect a 0, right? Okay, so you can do 2 things. You can drag the whole thing down. Okay, basically you Okay, the cursor, as I mentioned to you last week, I'm not sure did I mention this. There is 3 different cursor. One is this fat cross cursor. Then the other one is this double arrow cursor, which is for you to move things around. Or you go to the end, which is this thing called a hairline cursor or a target cursor, which for you to drag. Okay, you can drag all the way down if you want. Or if you are lazy like me, you go to this hairline cursor and you double click it. You will fill up the whole column for you. Okay. If you have done it right, only row number 6 in this should be 1. The rest should be 0.
And sorry, could you show again? I tried it and it didn't really work out.
For which one? Which step?
For the diabetic, the formula.
Okay, this is a formula. You type in the equal.
Yeah, I think maybe give me a sec.
What is the error it gives you?
Let me try again.
Try again. Okay, the rest besides Jing Xiang managed to get the answer.
Yes.
Okay, Jing Xiang, yep. Are you okay already? Okay, how do you know that you have the correct answer? Let you highlight the whole column G. Look at the.
I'm all good.
Huh?
I'm all good.
Okay. So you highlight the whole column. You look at this count 399 means there are 399 rows, and the sum is 62 means that you add up all the numbers is 62. So basically there are 62 diabetic. Look at this number here. Okay. Can you see? If you get the same number, then you're fine. Okay. So now we have coded the diabetic. Save the data sheet if you want to. Okay. Our next part is we want to look at BMI. Okay. So BMI is calculated. What is the formula for BMI? Anyone do not know a formula for, or anyone want to tell me what's the formula for BMI? Your body mass index. Okay. Sixian, what is the formula for BMI?
Is it weight divided by height times height?
Weight divided by height times height, correct. So it's weight. But what is the unit for this weight? It's in kilograms. Divide by height square, which is in meters. So it's actually meter square. Now, actually, anyone knows what on earth BMI means?
Body mass index.
Yeah, and it is called body mass index. But let's say your BMI is... Okay, how many of you never calculate your own BMI? Okay, anyone who is not afraid to tell me your BMI? Okay, so who are you
19,
first?
Lucas. 19.5-ish.
Okay, let's say 19.5. So what? Okay, so Lucas, what is your height and weight?
165 cm.
165. Okay, weight?
I'm gonna say about 57.
87.
57.
57. 57.
Yeah.
Okay, so what does this mean? So let's look at this number. And we kind of, I'll show you what on earth this looks like. Let me just go on. I'll take a snapshot of this guy and I'll show you what on earth it means. So let me go to my Excel.
Oh wait, the BMI is about 20 point something.
20 point something. Okay, doesn't matter. So let's throw this here. This is Lucas. Okay, so let's say your BMI is 20, it doesn't matter. Okay, 20. Okay, so what does this means in totality to our dear Mr. Lucas? Okay. Okay. So what does this mean in totality to Lucas Liu? Okay. So Lucas, this is how you look like. Let me just draw you. So you look something like that. Okay. Okay. The leg, the arms. So your height. Here is your height is 165. Okay, 165 here. Makes sense, right? Okay, this is how you draw in maths anyway. So what I'm going to do to Mr. Lucas is this. If I put you in a pen, in a square pen of 165 centimeter exactly. Okay. And what I do is I steamroll Lucas flat like a kueh lapis. So far, okay, ready? So Mr. Lucas is steamroll flat. Now, let me just find another color, if I can find another color. Okay. Animation, pen, okay. Forget it. Okay. So, after Mr. Lucas is steamroll, he becomes a flat piece of cake, 165 by 165. Okay. If I take 1 meter, so 1 meter will be somewhere here. So this is 1 meter, 1 meter by 1 meter. This block will be about 20 kilograms. That's what BMI means. It's actually density. Okay. So basically, BMI is to measure if I roll you out onto a flat surface, how thick are you? Okay, sounds a bit gross, but how thick are you? Okay. Now, in this case, our first step is to change the height and weight into kilograms and meters. Okay. So how do I change that? Weight convert into kilograms. Weight in pounds to kilograms is just multiply by 4.5. So okay. So from kg, from let's say pounds, I multiply by 0.45 to get kg. Okay. For height, okay, in meters, I will multiply the inches by 0.025. So basically, this will be the equation that I want. Now, to make our life easier, we insert one more column in M. Okay, so far so good. So we call column M as your BMI. Okay, let me just highlight here this column in BMI. Okay. Then what I do is I copy down the equation. Okay, I put the equation here. It will give me an error. In fact, it will give me nothing. Make sure I don't copy the first bracket. It will give me an error. Because what is W? W, I will go to my weight. So weight, H, I will go to my height. Then now this is my BMI. Okay, make sure you get the equation right. Okay, Jolene, are you okay?
Yes.
Okay, good, good, good. Anyone do not get the first answer, which is about 22.66.
Sorry, can you show how you did it again?
The equation?
Sorry. Yeah.
All right, look at this bar. That's how I did it. It is very hard to read, I know. The reason is I cannot expand this bar. I can expand this thing. Okay, you see, oops, what did I do? I can expand this thing, but this bar doesn't expand. Okay. Yeah. So this bar, you have to kind of squint your eyes a little bit to read. L2, which is the weight, times 0.45, that converts the weight into kilograms from pounds. K2 times 0.025 is to convert the height in inches to meters. Then I square it. Okay, so just now who asked for help? Are you okay already?
Yeah, I'm okay. Thank you.
Suyun, okay. The rest all right, right? Okay, so same thing. I will go to here, the side, and a double click, or you want to drag down, up to you. So the easiest way to check whether you're the right answer or not, just highlight column M and look at the sum. The total sum should be 11730 point something. Umaira, all right?
Yeah.
Okay, good. Okay, so now I have my BMI. But I still need one thing. If you look at the question, I will need to find this thing whether a person is obese or not. Obesity is by BMI of more than 30. Okay, question is this. Okay, let's do this part first. So BMI of more than 30. We have done the diabetes. We should be able to do this already. Right, we use the if statement. So here, I will just insert another column. And I call this obese. Change a slightly different color. And my obese is if my BMI is more than 30, then yes, 1 is obese, 0 is not obese. Okay, it's the same as what I did for my diabetic. Ryan, all right, you can get this already, Ryan? Ryan.
Yes.
Okay, good.
Yes.
So, not obese. The next one is obese, right? Obese, not obese. So, again, we have 166 obese in this whole data set. Okay, up to now, anyone needs to stop to look through. Okay, so at this moment, we have settled all the data sets that we want to use. Okay, which is quite fine. Now, basically, I will want to put it up onto your contingency table. So basically, what I will want is to do this. Okay, let me just go here. what I'm going to do is actually this part. Okay, let me just find out. So what I want to do is essentially this. Okay, diabetic. Yes. No. Okay, so yes is 1, no is 0. Okay. And I want to find your obese. Yes, also 1. No is 0. So I want to find for all this. Now, how do I fill up this table? That means I want to find the counts. Okay, the easiest way to use is this thing known as a pivot table in Excel. Anyone actually used pivot table before?
Wait, is that
Anybody?
the last predicle?
What?
The previous predicle, isn't that the pivot table or not?
I can't remember, but maybe it should be. Yeah, it should be. It's the same pivot table. I think I did mention in the last predicle before. Correct. Okay. So same thing. What I want is to pivot table. I will highlight every of the cells. I go to insert pivot table. This is what we did in the last practical. Okay. So your pivot table, you go to another sheet. So we bring this over. So now what I want to do is this. Okay. Since my diabetic is in the columns, so I pull down my diabetic to the columns. So it's 0 and 1. Then I pull my BMI or obese into the rows. So I get this. Okay, so far?
Wait, can you show the pivot table again?
You mean how do you open up a pivot table or how do I use a pivot table?
How to open up pivot
How to
table?
open up. Okay, so this is what I will delete this sheet. How do you open up a pivot table? Simple. Click on this, the top left hand corner, upper left hand corner. You click on it, it will highlight the whole table for you. Then you go to insert here, insert, look at my cursor. Click on insert. Pivot table is the first one.
Okay, Ken, thanks.
Okay. Then you click OK. All right. So same thing, let me repeat. Columns is diabetic. Okay. Obese is rows. Okay, all of you got up to here?
No, can you go back? Can you show again the how you put the row labels and column labels again? Sorry.
So you see, columns, since I want the columns to be diabetic, right? I just click on it, pull, drag, and drop into the columns. See this? I drag into the columns. Okay. Same thing for obese. I drag and throw inside the rows. Okay.
Okay, I got it. Thank you.
All right. Okay. Okay. Then after that, I just go to either one, diabetic or obese. I don't bother. I drag. That's why I drag the obese. I throw inside values. Obese, no. So here I'll have to throw diabetic. Hold on. See what it does here. Okay, values, rotate, protect sheet. Okay, don't have a border of protect sheet. Format cells. Rows, column, get obesity, count of obesity. Okay, obesity, where's my obesity? Obesity. Now, do you get this value first? All of you got this value already? Do you end up with these values first?
Yeah.
Okay, but this is a sum. I do not want the sum, I want the count. So I go, look at this arrow here on the side. I click on it. I can change the value field settings. Okay, you click on change value field settings. You change it to count. Here I have sum, count, average, and so on. I change it to count. Okay, change the second one, change it to count. Then click OK. So this is the count. So far, so good.
Cher can repeat.
Okay, so originally, when I pull down the obesity into values, right? By default is sum, correct?
Yep.
Okay. So who are you first? Okay, next time please tell me who are you. Okay, then on this, look at where my arrow is, my cursor is. There's this little arrow at the side. Click on it. You can change the value field settings. Okay, click on this change value field settings. Then the next one, you want the count, you want the sum. Then you click OK. All right. Just now, who is that?
I'm Sixian.
This. Okay. You managed to get these values already?
Thank you.
Okay. Good. Okay. So now the problem is this. If you look at so you click on this column labels. Look at my cursor here, column labels. I will have 1, 0, and blank. I can throw away the blank. Blank means no data. Don't bother with it. So truncate. Rows. Okay. Also blank, I can throw away. Okay. So I come out with this. Okay, basically, I remove the blanks essentially. Now, is this a correct contingency table that we want? Okay.
No.
Who are you first?
Oh, sorry, Xavier.
Xavier. Okay, Xavier, is this a correct contingency table that we want?
No.
No, right? So what's wrong with it?
Don't have the condition. I never put a
Okay,
table
doesn't matter.
condition.
But is the row and columns correct?
No.
No, right? Because it's actually the opposite. You look at here. It is the opposite of what we want, right? It's actually no, yes, no, yes, instead of yes, no, yes, no, correct?
Yeah.
Correct. So what we want to do is have to rewrite the whole thing ourselves. Let's say we have here. So what is yes and yes? Oops. Yes and yes is 34. Correct. So this is 34. Yes and no is 132. Okay. No and no is 204. Then here is 28. Make sense?
Yeah.
Okay. So now what we is to make our life a little bit easier, we kind of okay, so we write it ourselves here. Okay. So we write it as obese, not obese, diabetic, not diabetic. So it's basically since there are only 4 numbers, right? So we literally rewrite ourselves. 34, 132, here will be 28, and 204. Yep. So that is what we have here. So far, so good?
Yep.
Okay. Then what we do is we can calculate the OR and RR, but to make our life easier, we just add up these 2 numbers first. Okay, for the OR, for RR. Okay, so this is the total. But this is the values that we want. So, okay. Now, so what is the RR and what is the OR? Okay, again, which one divide by which one? Okay, Bernice. So relative risk, which number and which number? Bernice.
Hi, 34 divided by 166.
166. Okay, then
Then divided by 28 divided by 232.
no problem. Okay, or else you can just do a substitution yourself lah. Okay, then okay, so Yamamura, how about odds ratio?
Yes.
What's it? Which one divide by which one?
Uh,
Okay, refer back to here, odds ratio. Okay. Yep. Give it a try, give it a try. It's okay to be wrong.
34 times 204
34 times 200 and what?
and 204
Okay.
divided by 28 times 132.
Right. Yeah. So this is the relative risk and odds ratio. So what does this values tells you? Okay, let's see who. Okay, yep, nothing here. Okay, so basically we have computed the odds ratio and relative risk. Okay. So essentially, what does this tell? What does these numbers tells you? Is there more risk of diabetic when a person is obese, or less diabetic risk when a person is obese?
More risk.
More risk, right? Actually, I kind of just messed it up again. Obese, rows. Okay. So this is actually the other way around. This is diabetic. No wonder the numbers were so fun. Diabetic, not diabetic. This is obese, not obese. Okay, did I get the numbers right? 204, yeah, correct. So obese and not obese. Okay. So you have actually almost 69% more risk. Actually, between 69 to about 77, 88% more risk of diabetic if a person is obese. Okay. And remember, what is important is the obese and non-obese criteria is based on BMI above 30. So this is BMI, um, more than 30. Okay, not obese is BMI less than 30. So you can actually rate what is the, let's say if BMI is 35 or BMI is 25, how does the relative risk increase? Right? So you can actually do a multiple plot. Now let's say BMI is 30. You have the odds ratio of 187. Okay. What you can actually do is something that looks like this, which can be quite interesting. You do this. Okay. What is the odds ratio when the BMI is increased? Okay, okay. So you may have at the moment the BMI is 30. We have a value here which is 1.87. How about when BMI is 25? When BMI is 20, so what is the risk when BMI is 35? You can actually do a plot and see how the risk actually increases as BMI goes higher and higher. That can tell you a lot about what is a BMI that is acceptable. Make sense? Jolene, am I making sense to you?
Yes.
Okay, all right. Okay, let's try. Okay, this Jolene. Charles, making sense to you already?
Yeah.
Okay, so you can actually plot different things. And this is actually a good graph to help us figure out, okay, what is a acceptable BMI? Maybe this is not the correct graph. Maybe the graph will look something like this, okay? 30, so you may have a very steep increase, and then the curve may actually goes down this way. So what is a acceptable BMI? Okay, so essentially that is the main part that we are dealing with. It helps you a lot. So here you can fill out all your numbers. It's basically the same numbers that we have. Okay, so okay, so here this is the numbers that we have. This is 34 and 128, 132, 132, 28, 20 something, right? 204. Okay. Then you can calculate the risk ratio and relative risk. Risk ratio is also relative risk or the odds ratio. Okay. Now, the question that I have for you is, in being a biomed student or biology student, are we having more obese problems or less obese problems these days?
More.
More,
Easily.
right?
Yeah.
Okay. So let's look at the WHO obesity chart. What am I doing? Okay. WHO on BMI standards. I'm not sure whether you call it standards or not. Let's try. It can be quite interesting. Just by looking at it, it tells you a lot of information. You see, the number of population above BMI of 25 is actually quite high. Okay, in different countries. Let's look at some of the other charts that we can find. This is the same thing. Let's look at other graphs, tables, images you can find. Okay. Yep, this is a simple one to read. 30 underweight. No, no, no. Okay, so let me just figure out another table for you. Okay, this. This is quite a easy chart for you to read about obesity. Where on earth is the chart when I want it? Okay, doesn't matter. Let me just run it down. Okay, you look at this chart, it's a bit small. So why is BMI a problem? We look at how many levels are there above normal, and underweight is only one level. It's just underweight. Normal is, for WHO, is 18.5 to 24.9. Okay, overweight is from 25 to about 30. Pre-obesity, obese 1, 2, and 3. So there are people who are more than 50. That means you're actually twice the weight that you're supposed to have. However, there is a difference between the WHO cutoff points and the Asian population. You realize that Asian population is lower. Okay, so the Asian population, if your BMI is actually 23, you are considered overweight already. But in WHO standard, you are still under normal. If you are, so it does based on the body shape as well. Okay, so obesity is a worldwide problem. We are starting to have a very serious problem with it, even in Singapore and all this stuff. Now, how many of you have seen I would say seen primary school kids that is quite overweight? Have you seen primary school kids these days that are quite overweight?
Yes.
Yes, right? And or you have seen primary school kids who are really overweight?
Also yes.
Also yes, right? Okay. Now, how many of you realize that, especially for teenagers, yourself and below, when a person tends to be quite overweight, you have this very dark ring around your neck? How many of you realize that or seen people who have that? That means they have a dark ring around their neck. It's almost like they never shower. Anyone realize that?
Yes.
Okay. That is first stage of insulin resistance already. That means the body is starting to be resistant to insulin. Okay, when that happens, it means that the person's skin cells is actually dividing faster than the skin shredding process. Basically, you're growing too fast, and the person is actually getting into pre-diabetic situation. Okay, so the actual name for it is this: acanthosis nigricans. You can go and type online. You can go and find out. There's a scientific name for that dark ring on the neck. It can be on the neck, can be on elbow, or any parts of the body. So far, so good?
Yes.
Okay. All right. Now, so basically, we have essentially finished most of the things. So we have found the relative risk. So why not you do exercise 2 yourself, task 2. How about the relative risk by genders? Does it matter in genders? Okay. So we will need to redo this part, and then what we need is by gender, we put inside the rows. Okay. So this is the difference between male and females, does it differ? That means by gender first. Okay, what is the relative risk and odds ratio if you are male or if you are female? This is in totality. How about if you are male and female, does it make a difference? Okay, so let's do this stage and we'll see. So this is male plus female. I'll say this is total. So you do it for the other.
Sorry, how do you edit? Like, where do you get that?
This part, right?
Yeah.
So let me just originally have here. Now what I do is
Sorry, I meant how did that pivot table feels? Like, how do you get it to appear? Sorry.
okay. So basically from here, this part, correct? Or what do you mean get it to appear?
Like, how did that table at the side appear where you can drag the different?
Okay, so I start with here, right? Now this originally this is what you have. You want to make this part appear. Am I right?
Yes.
Okay. So you go onto the actual pivot table, you right click, then you show field list. Click on show field list, this will pop up.
Okay, thank you.
Okay. Then what you do is you grab the gender and put it above the row of your obesity, obese. So it cannot be below, below you end up with something like this. Okay, you have to put it above the obese. So it is by gender, then by obese 1 or 0. Okay, so let's do this for males. So males, you are looking at these numbers here. Okay, so males, this is 11. 11. Here is 0, right? No, 11. 11, 39. This is 16. 16, 100. Okay. Then basically you just change the values yourself.
Sure. I cannot. Every time when I click on the Excel, right, they prompt me with alert. We can change this part of the pivot table.
No, you cannot change. You cannot change.
But I don't know how to go back.
Okay, you click on here. Let me just read. You click on any part of the pivot table. Right click, right click, right click.
Yeah.
Then you go to show field list.
I don't have that option.
Then what option do you have?
Cut, copy, format cell, drop down list.
Okay, so that means something is not right. Let's see, because I have it.
But anywhere I click, right, it says we can change this part of the pivot table.
So the easiest way is to redo the whole pivot table again lah.
Oh, okay. Okay, I try.
Yeah. Okay, so if you do it correctly, these are the answers for males and females. So I highlight for males. These are answers for females.
Sir, how did you get both the diabetic and obese pivot table and the male and female pivot table like integrated?
Okay, so originally what I have, let me just show you again. This is what I have, right? Okay, let me just throw up. So this is a pivot table I have originally, right?
Yeah.
Who's that first?
Damien.
Damien, okay. So what you do is this. Let me just show you. Okay. So from here, the fields itself, you want the gender. You click on the gender. Then you drag it to the rows. And you put it above the diabetic, obese. So remember, look at this green line. Okay, on the screen, this green line is where you put the stuff. I put on here. Now there's two. It is sorted by gender, then by obesity.
Oh, okay. Thank you. Thank you.
Okay. So you can actually zoom down into a lot of different things. You can even sort by gender, then sort by body frame, then sort by obesity. Okay.
Yeah. So also we can swap the cells around, right? So that it's in like 1 and 0 order.
You
like
can, but then it is much more difficult because every time you add something, right, you have to restore everything yourself. So you must just, this is for you to make your, it's a pivot table is to summarize the data for you. So you already have the summarized data. Now it's just to rewrite it out only.
Okay, thank you.
All right. Okay. Anyone have problems so far? You realize that the males, whether you're male or female, the relative risk versus of obese versus diabetic is actually different. Okay, this is a biological difference between males and females, which means that based on our data, females are more prone to diabetic if the person is also obese compared to males. Okay, because male is about 1.6, female is about 1.9. Okay, that has a lot to do with the hormonal differences. So far, so good. Anyone unable to get the males and females numbers? Jordan? Okay.
Yeah.
All right. Okay. So the last part that we want is this thing called a Simpsons Paradox. Now, Simpsons Paradox is a real-life example whereby if you look at this, okay, you look at this data alone, right? It's actually from a paper. You can read the paper yourself. Okay, so which method is better for which open surgery or recutaneous is better for stones that is less than 2 millimeter or 2 centimeter? Which one seems to be better? So you don't want to do this part, don't look at it. Go and read through this thing known as Simpsons Paradox. Okay, Simpsons Paradox is actually a classical example in biology. So you just type Simpsons Paradox. You will go and look at this thing in Wiki, which is actually quite relevant. The classical Simpsons Paradox is the kidney stones treatment. Okay, so you read through this example. It basically tells you this where we get data from, treatment A and treatment B. If you look at treatment A seems to be better for both large and small stones. Okay, but if you compare it in totality, treatment B seems to be better for any of the stones. So there's a paradoxical argument here. So is it treatment A better or treatment B better? Since you say that treatment A is good for small stones and large stones, but treatment B is good for both small stones and large stones. Doesn't make sense, right? That's called Simpsons Paradox. Okay, do take note that there's such thing available. The reason is there's actually this thing known as a confounding variable, which is the patient going for treatment A and treatment B is actually not random. It's based on the surgeon's or the doctor's advice. So the doctor actually do advise one treatment versus the other. Okay, and that is what causes the differences. So there is a favoring for one treatment over the other. That's what causes Simpsons Paradox. Okay, so don't be surprised if you see a situation that looks like this. Okay, that is a bit extra for you to understand for Simpsons Paradox. Okay, you may not appreciate it at this moment, but know that there's actually such thing around when you do your data analysis. Okay, so far any problems? Jingru, any problem?
No.
No. Okay, Charles?
Nope.
Nope. Jermaine?
No.
Damien?
All good.
All good. Okay, Jolene Heng?
All good.
Good. Jordan? Min Hui?
Yeah.
Yeah, Min Hui, all right.
Yeah, okay.
Okay, Lucas?
I'm good.
What? Yeah, right.
I'm fine.
Fine, okay. Umaira?
Yeah, good.
Okay, good. Shuyun? Ryan?
Yeah, good.
Good.
Good. So? You know?
Yep. I'm
Okay.
good.
Sixian?
Yeah.
Okay, Jingyun?
Yes.
Jolene Teo?
Yes.
Trevor? Venice?
Yep, can.
Yes.
Xavier?
Yes.
Yes. Jingxiang? Yamamura? Zul?
It's Saki.
Yes. Okay.
Huh? So what am I supposed to call you?
Saki.
Zaki, okay. Zaki, Zul, all right. Okay, so basically, let me just save this whole thing, and I'll call this, rename, I'll call this, what am I going to call this? I'll say it's relative risk, RR and OR, okay? So to make our life easier, we will use this as we go along, okay? So what am I going to do at this moment is, okay, what am I doing? Okay, let me just save this as well. Save options. This is lab. Okay, hold on. Just let me save up my stuff. Course materials. Biological data analysis. Laboratory. Hold on. Course materials. Laboratory. laboratories. Okay, laboratory. So this is lab 2. Laboratory 2. Let me save this part. Okay. Okay. Then what I do is, why do I have this funny thing? Lab operator manuals. Okay. So we are doing contingency tables here. So this is the work examples. Okay. Now what I will do at this moment is I will drop you the file so that we can continue using this file the following week. File here. Okay. Okay. Save this file. So I send the file over already. All of you go and save the file onto your own machine. So we'll use this file. Okay, every week we will kind of just do this as we go along with this file. So at least you know what have been going on. And let's say if you mess up your own data, you still have something to follow. All right. Okay, that's all for today. We'll see you next week. No, next week is no lesson. So next week is a flex week. So we'll see you the week after this. Good?
Okay, Joe.
Okay.
All right.
Thank you.
Fun.
Okay,
Bye.
thank you.
Okay, thanks, Joe.
Thanks, yeah.
Thank you.
Bye.